Hello everyone. In this video, we're going to solve synthetic divisions. Is how you can divide a polynomials by a polynomial. So we're gonna call them also algebraic expressions and how to divide them. First of all, before you start with the divisions, you need to make sure that the exponents are written in the ascending order. That means if exponent 4, exponent 3, exponent 2, exponent 1, and exponent 0. So let's start with the first one. We see exponent 4 is fine. Because we don't have exponent 3, we're going to do 0x power 3 minus 4x squared plus 2x plus 6. As you see, the exponents go in the ascending order: power 4, power 3, power 2, power 1, and power 0. So we know this is divided by x minus 2. How do we proceed with the division of, synthetic divisions? First of all, what we do, we write the coefficient of each term. We have 1x power 4, we have 0x power 3, we have negative 4x power 2, we have 2x, and we have 6. As you see, we take the coefficient of each of them and also adding the constant term. We set it this way. Now, it is divided by x minus 2, and we're going to take only the constant term, which is minus 2. Instead of writing minus 2, we're going to write positive 2. So we do that. If it was divided by x plus 2, we're going to divide by 2, by negative 2, but because it's x minus 2, we're going to divide by 2. We only change the sign in the denominator, or the sign in the divisor, but not keeping the x. That's why we call it synthetic divisions. Now, how does that proceed? First of all, we can set a bar underneath. We bring the first digit down. Now, this digit, we're going to multiply it with this one. 1 times 2 gives us 2, and we write this 2 right here. Now, we add 0 to this 2. 0 plus 2 gives us 2. Again, we multiply this 2 by this 2 again. And 2 times 2 gives us 4. Now, let's add negative 4 plus 4 gives us 0. Now, we multiply again this 2, this 0 by 2. 0 times 2 gives us 0. Now, let's add 2 plus 0 gives us 2. Again, we multiply that 2 with that 2. 2 times 2 is 4. Now we have 6 plus 4 is 10. What we were expecting is to have the last term equal to 0, because the last term is the remainder. Unfortunately, in this case, the last term is not 0. So we have a remainder 10. Because the largest exponent is power 4, so we expect the first term here would be power 3. That's the first term we're going to have, because the largest term in our divisions, the largest term in our divisions is x power 4, right? The largest exponent is power 4. Now, the quotient, because this one right here gives you the quotient and the remainder, right? That would be the quotient. And the last term right here is the remainder. Now, let's say, because we had power 4, we know the first term would be power 3, the second term would be power 2, the third term would be power 1, and the last term is the constant. Now, you see, if we want to write the solution to these equations, we know it would be x cubed plus 2x squared plus 0x plus 2. Is that for us, we're going to have x cubed plus 2x squared plus 0x plus 2 plus the remainder. The remainder is 10 over, the divisor, which is x minus 2. But in this case, the question they ask us use the synthetic division to find the quotient. So the quotient for this divisions, we can usually we call the quotient q of x. So q of x here would be x cubed plus 2x plus 2. We don't need to put the plus 0 plus 2x squared, x cubed plus 2x squared plus 2. We don't need to put the 0x because we know if you have one term missing, that means the coefficient of that term is 0. Now, what is the remainder? Because they ask us also to find the remainder. The remainder in this case also is r of x equal, what is r of x? R of x is simply equal to 10. So we don't need to add r of x here over x minus 2. If you add r of x over x minus 2, then it should be in the same term. But because they simply ask us for the remainder, we're gonna leave it like this. You don't need to put it over x minus 2. So this is the first one. In order to have more space to do the second one, I am going to copy the slide again, and so we can have a second slide. Let me remove this. Now, in the second examples, first of all, we verify, we double check that the exponent are in ascending order. We have power 5. We expect the next one will be power 4, power 3. We see power 5, power 4, power 3, power 2. Oh, we see no power 1. Then we're going to add it. So we're going to rewrite it as x power 5 plus 4 power 4, x power 3, x power 2, 0 x power 1. So we don't need to write, we need to show this term is right there, and it's going to be divided by x 2x squared minus 1. Now, this one, they ask us to use long divisions. Remember, you have two techniques, two methods you can use to divide a polynomial by another polynomial. So you can either do long divisions or you do synthetic divisions. Unfortunately, not in many cases that you can use synthetic divisions. That's why using this one is important. Now, let's write the whole term. We don't need to take the coefficients. We need to write everything down. So 2 x power 5 plus 4x power 4 minus x power 3 minus x squared plus 0x plus 9. We're going to divide it by 2x squared minus 1. Now, we need to cancel one term at a time because our first term we want to cancel here is this term. You said by what I should multiply 2x squared to have 2x power 5. Yes, you can only multiply this one by x power 3 because x cubed times 2x squared gives us 2x power 5. Now, because you see what it is, I can erase the circle that I was using. So I can erase this and erase this. All right. Now let's go and use what we were doing. So x cubed times 2x squared is give us 2x power 5, but when we write it down, we changes the sign. It was positive, now we write it down negative 2x power 5. But even though we want to cancel out one term at a time, in the divisor, we have two terms. We cannot only go and multiply x cubed by only 2x squared. We also need to multiply it by negative 1 because we have negative 1 there. So we do x cubed times negative 1 give us negative x cubed. So now when we write it down, instead of writing negative x cubed, we're going to write positive x cubed. So we're going to have positive x cubed. Let's do the first divisions. As you see, the first term is gone. We have left now 4x power 4. Oh, x cubed is gone also. I didn't expect to see this gone. And now we have minus x power 2 plus 0x plus 9 if you want to write everything down. Now, the next term, remember, we try to cancel only one term at a time, not two. We cancel only one term at a time. Now, I have 4x power 4. I said, by what I should multiply 2x power 2 to have 4x power 4? Yes, you need to multiply 2x power 2 by 2x squared. Because now 2x squared times 2x squared give us 4x power 2. Is that correct? Yay, let me erase this so we can have enough space for that. All right. 2x squared times 2x squared give us 4x power 4. But when we write it down, the sign change is going to be negative 4x power 4. Because we don't only have 2x squared in the divisor, we need also to multiply 2x squared by with negative 1. So 2x squared times negative 1 gives us negative 2x squared. But when we write it down, it's become positive 2x squared. Cancel out the first term. Now what we have left is only x squared plus 0x plus 9. Okay. Okay, now we want to cancel only x squared. But the problem, look at in your divisor. The divisor have 2x squared, but now we're looking for x squared only, not 2x squared. So to get x squared, we need to multiply 2x squared with 1/2. Oh, you can have also fraction. That's fine. So 1 times, remember, if you do 1 times 2x squared, I mean, not 2x squared like this, 2x squared, that would be 2x squared over 2. You see, you can simplify and you have x squared left. So 1 times 2x squared gives us x squared. 1/2 of 2x squared gives us x squared. Positive, when we write it down, is become negative x squared. 1 times negative 1 gives us negative 1/2. When I write it down, it's become positive 1/2. Okay, let's make this happen because we're gonna have positive 1/2. Okay, now what happened? We go into, let me make enough space for this one. I'm gonna erase this and show you. Okay. Now look, once we do that, give me 1 second. Okay. Once we do this division right here, we end up having 9 plus 1/2. What is 9 plus 1/2? If I have 9 plus 1/2, I simply need to get the same denominator. 2 times 9 is 18 over 2 plus 1/2. Same denominator, you can add the numerator. So we have 19 over 2. So this one right here would be 19 over 2. Is that correct? All right, all right, all right. So what we do, I am going just to erase again because I need space. Let me erase this one. I need space. Now, the questions they asked me was, what is find the quotient and the remainder. So you know now the quotient. That we can call Q over X equal x squared, x cubed plus 2x squared plus 1/2. This is the first questions we answer. And the second question is to write down the remainder. In regular cases, we were going to write 19 half, okay, 19 half over 2x squared minus 1. That would be 19 over 2 times 2x squared minus 1. But here we're going to just keep the remainder as is, as 19 over 2. But as I said, in many cases, remember, when you do these divisions, let's say I can rewrite the answer for these divisions for you. If they ask you, depending which format they want you to write this answer, you can rewrite the answer for this particular divisions, because we do that already. Let me just erase. I'm going to erase what you see here. All right, and what you see here, okay, we could definitely write the solutions here as what did we find? We find x cubed plus 2x squared plus 2, x cubed plus 2x squared plus 2 plus the remainder. What was the remainder? It was 10. So we could write plus 10 over x minus 2, and this answer would be correct. And in this case also, so this answer is when they don't ask you to specify to specify for the quotient and the remainders. If only they ask us to perform this synthetic division. The same, if they said perform these long divisions, then the solutions was going to be for this one, x cubed x cubed plus 2x squared plus 1/2, because it's a constant, plus 19 over 2 over 2x squared minus 1 when we multiply by the reciprocal of the second fraction. So you would see the answer for this one would have been 19 over 2 times 2x squared minus 1. That also would be the solutions. I hope these two examples help you to better understand how to perform synthetic divisions or long divisions of polynomials. Don't forget to subscribe for more video. I'll see you soon. Take care.